Right, well, welcome and thank you for joining us for today's webinar, Practical AI and FieldTech Implementation Strategies, brought to you by GeoLeak News and sponsored by Fulcrum. I do have a few housekeeping notes to go over before we officially get started. If you need any technical assistance, we first recommend refreshing your browser. That typically solves most problems. But if you continue to have any issues, please use the Q&A box and I will respond right away. There is no call-in number for today's webinar. To connect, you just need to have access to either a computer, tablet, or cell phone for audio. And note that everyone has been muted. For your convenience, everything in the webinar console is fully customizable, so you can move things around, resize the windows, and even turn on captions for this event. At the bottom of your console, you'll also find a resources box where you can download the slides from today, and we also added some additional content for you guys. So make sure to take a look there. And you can utilize the Q&A box at any time to ask your questions. And at the end of the webinar, we'll leave time for a Q&A session with our speakers today. If we're not able to get to all questions, I'll make sure to send those over to our sponsor for follow-up via email. And finally, this webinar is being recorded, and you'll receive a thank you email with a link to access the webinar console again, to replay the webinar as you wish, and to download the slides and any resources. You'll receive that thank you email within the next 2 business days from GeoLeak News. So with that out of the way, I'd like to welcome our speakers for today. We've got Coleman McCormick, VP of Product of Fulcrum, Zac McCormick, CTO of Fulcrum, and Jared Carey of TREKK Design Group. So at this time, I'd like to welcome our speakers to begin the presentation.
All right. Thank you, Laura. Hi, everyone, and welcome to today's webinar. I wanted to thank you all for coming and expressing interest in some of the latest things we've got going on in the world of field technology and how Fulcrum, along with our customers, are thinking about and approaching AI to augment field work. As Laura said, my name's Coleman McCormick. I'm VP of Product here at Fulcrum. And today I'm joined by Zac McCormick, our CTO, who will be diving a little deeper into our strategy with AI, along with a demo of some of the kind of neat new things that we've been working on to bring that technology into the field. And we're also joined today by our friend Jared Carey, who's a Senior Innovation Specialist at TREKK Design Group. He's going to give us some practical examples of what TREKK is doing with Fulcrum, FieldTech, and AI use cases in their work with stormwater infrastructure. So first, let's look at the agenda that we've got for today. To kick it off, I'll go through a quick overview of Fulcrum and our approach to FieldTech and what that means to us, harnessing GIS for inspection work and how we're thinking about AI. Then Jared's going to show us some of the innovative stuff that they're doing to evolve field processes using Fulcrum, along with tools like 3D cameras, GIS, and GPS devices over at TREKK. And then Zac's going to deep dive on some of the latest that we're doing with AI and Fulcrum. And then we'll wrap it up with, hopefully, we'll have plenty of time toward the end for open discussion and Q&A for us to answer any questions that you have about what we're talking about today. So let's get started. I'll start with some brief thoughts on what Fulcrum does and how we think about our business. At the core, we're focused on capturing and sharing all of the data that you need in any field-oriented situation. So that means we help customers get complete and accurate field data and make sure that your teams are highly productive while they're collecting it. So that means it'll take less time than it would on paper or with other solutions. We do this across any use cases. So you'll improve data quality and performance everywhere in the field with field operations. And that sort of consistency helps you get better analytics, drive digital transformation efforts, and create significant impacts wherever you need field data. So we're all about capturing and sharing the data that you need in the formats and in the best formats and best places that it's consumed. So I'm going to go through here a process comparison, we're going to look at what makes Fulcrum, how Fulcrum kind of changes a process from what a typical customer workflow would look like. So we'll start with a typical profile of someone in the water utility business. So a water utility inspecting existing stormwater infrastructure. And this is a use case that Jared will show us more about in practice here in a few minutes. But it sounds pretty simple, right? They're just checking boxes on a form, but there's a lot that needs to happen and a lot they need to know to get this work done. So first, we look at the process before Fulcrum. So they need to be able to navigate to and select the right asset. And sometimes these are kind of densely packed together and not trivial to identify. They need to get access to the asset, which even that sometimes can be a challenge. They need to log precisely where, let's say, a drain or manhole or some other asset is located. They'll need to conduct the inspection, collect images, pictures, video, and other documentation, and then be able to put it all back the way that it was when they got there. And it sounds simple, but there are many steps in the process to get it right. And a lot of it is actually logistics around the actual inspection process. So what we try to do is help to simplify the inspection process as much as possible so that you're not distracted or causing data problems given that there's so much other like logistical challenge to working in the field in general. And a typical process, looks something like that. But if we look at it with Fulcrum, it's a lot more straightforward. So we based our process on a customer basically will download the asset to their laptop. 1 second here, missing my notes. Yeah, to say a little bit more about the pre-process. So they'll even something like photos in a world without Fulcrum sounds trivial, but it's actually can be a lot more complicated because you've got to be able to collect the photos and then be able to track which photo went with which asset, hopefully be able to match them up later on. And then you've got transcribing, reconciliation, retyping, uploading. A lot of that can be a huge effort. But with Fulcrum, you can drive to the asset, perform the inspection, and then go to the next one. So we're trying to really streamline all these steps into a single simple workflow. The data is already there. The asset info is already there. Photos and videos are automatically matched up and uploaded along with the inspection. Everything's captured and no additional work. So this means doing a lot more in less time, getting better data, and your field teams will be a lot happier in the process. Next here, I want to look at what this process would look like with Fulcrum, but with and without like our FieldTech and AI integration that we're talking about. When you start your process, given a tool like Fulcrum and a platform like Fulcrum to be able to do what it empowers your field operations to do, we can layer in other steps to this process to automate certain aspects, to enrich data, and to do things that we really couldn't do at all before having a tool like Fulcrum. So new things become possible, like fetching weather data based on current time and location into an inspection report, scanning barcodes to look up assets in a database, taking native video and photos right with the same device, automatically detecting defects and issues using images, and this is something we'll see more of here in a few minutes. And then having forms that adapt to given situations. So being able to build in logic into a workflow that creates a sort of if this, then that style of workflow, customized to your specific needs. And then to automatically deliver tailored PDF inspection reports to customers or to stakeholders in real time, right as the work is completed. If we look at this when we layer in the embedded AI and FieldTech that we're talking about, it gets even more interesting at kind of automating a lot of these steps in the process. When we talk about Fulcrum and where it sits in the technology stack, we like to think of it as a field system of record. So not necessarily a system of record in the sense of a primary system for all enterprise content. So think like ArcGIS for your GIS data, or a SAP or something like that as an ERP system, but as a system of record for everything that's happening in the field. There are dozens of different types of work that can happen in the field, and every organization, and we look at existing Fulcrum customers and what they do with the product. Every customer has dozens or sometimes even hundreds of separate processes and workflows that they're building into Fulcrum and building around Fulcrum. So it becomes basically the system of record for all of those operations. So inspections, preventative maintenance, installations, permitting, safety audits. Each and every one of these has its own demands regarding data. So there's different places the data needs to go, different reports need to come out of it, different devices and technology to perform the work in the first place. And we're trying to kind of centralize all that into a single layer. We put together this graphic to highlight kind of where Fulcrum sits in the ecosystem of technologies that you might have inside your organization and how it stitches these different systems together. It's organized in kind of a time workflow, or a time kind of presentation. So we look at it from prior to the activity, during, and then after. And Fulcrum makes the best use of these FieldTech systems. So tools, we define FieldTech as anything that you're using out in the field that augments work that you're doing. So it could be drones, cameras, GPS units, and it doesn't have to be hardware either. It could be data sources that you need access to. It could be imagery. So Fulcrum can harness all of that and bring in FieldTech data where necessary. And then the same on kind of the back office end. So resources like enterprise databases, asset management systems, GIS, data warehouse, Fulcrum can pull from that as needed too, and kind of fold it all together into a single pane of glass for working in the field. And so prior to the work, we've got to assemble the required data needed to go perform the work. So we're bringing together things like maps for reference information, the team information for tasking out the work, and it can come from different kinds of data sources. And then during the activity, while you're actually performing inspections, we might need the tablet to connect to a GNSS device for higher accuracy for certain use cases. And then others, we may just use the onboard hardware. You can use other sensors or other tools for things like scanning barcodes. You could pull in data from a web service, something like weather data or parcel information that you can pull in and embed into your reports. And then we may also be doing things like pulling data from the back office in real time, like dynamic calls to our internal ArcGIS environment, or driving like real-time alerts when critical conditions are found in the field. And then post-activity, after the work's finished, we can push the data to all the relevant systems. So when a given inspection is completed, parts of that data may go into an asset management system. Other parts may go into a data lake or some kind of long-term storage for things like photos or something like that. And we can push that data wherever it needs to go. And so in addition to being the field system of record for doing inspections and field work, Fulcrum kind of functions as this connectivity layer between different tools and data sources. And the goal is to bring the right data, the appropriate data together at the right time, right where you need it. So with that, I'm going to turn it over to Jared Carey. So TREKK has been a longtime Fulcrum customer and one of our most impressive power users, and you'll see that in some of what Jared's going to show us. They really flex all the muscles of the product and what it can do, and really have done some incredible work with FieldTech in their infrastructure work. So we'll turn it over to you, Jared, for this next section.
Yeah, Thank you, Coleman. This is always exciting. I watched Fulcrum grow from beyond 10 years ago at my last engineering firm I worked for. So I've been at TREKK for 10 years. I'm Jared Carey, and I'm the Senior Innovation Specialist, as we call me, here at TREKK, trying to come up with technologies to leverage for the civil engineering world to make our jobs easier. We're multidisciplined. We do transportation, traffic, water, wastewater. We've used Fulcrum in almost every one of those capacities, but mostly we found a great fit with the water and wastewater teams. We also do utilities, electric and things, but a lot of inspections, a lot of underground inspections. We've got 200 employees across 9 offices in the Midwest. Roughly 25% of that is our field services team, and there's about 14 crews floating around right now using Fulcrum on a daily basis for our data collection. We've tailored it for smoke testing, manhole inspection, stormwater, a lot of different things. And then we also found that we can use Fulcrum for asset management internally. Where did all of our cameras go for flow monitoring, et cetera? A lot of different nimble cases, but we're pretty excited about it. So to give you some challenges from the field, when I first came on board 10 years ago, all I saw was efficiency issues. I said, okay, guys, we have to do confined space entry in a manhole. And that means safety issues. We've got paper, sketches, photos that don't have comprehension. So you're looking down in the manhole, and like that bottom photo, are we looking north? Where are the pipes? There's a lot of questions that I have. And the papers, the field sketches, it's hard to read some people's writing, and maybe they wrote it down wrong, or the field sketches just aren't AutoCAD, right? Well, we tried to mitigate some of this 15 to 10 years ago with pole cameras, where we would take a camera on a stick and would stick it down there with a timer, try to get up in front of pipe number 1, take a picture, reset the timer, put it at pipe number 2. And that takes a long time too. And then also with all of this, because the records are going between paper or an access database, and external photos, it was just so easy to have omissions of missing photos, for instance, or errors because we got the wrong manhole ID, especially if we're shooting GPS separate of those systems and it's in its own system where you have to type the manhole ID and join it later to the database. So a lot of challenges. I was frustrated. So I said, okay, let's start with how do we comprehensively look at a manhole? And at the time, 360 cameras were coming out. Ricoh Theta, the M15, was the first flagship camera we adopted. It was awesome. We had a great time with it. The quality, of course, was brand new. It was a lower resolution at the time, but we just needed some good lighting. So over the last 6-7 years, we've perfected that internally. We added extra lights. We built our own lights, built a 3D printed rig to lower the camera. The cameras got better. Ricoh now makes the Z1 camera, which has amazing optics. So what happens is we get this 360 comprehensive view. The pictures are huge. You can zoom in and anywhere, look up, down. It's like Google Street View for the sewers, for manholes, at least. So when we took that, we got these panoramic visuals. So in the bottom right corner, the picture, just imagine clicking into that picture and panning around in all directions. So it's not just one picture, it's every direction. Okay, so then we learned just a few years ago, we can make 3D models out of this stuff. So we took those pictures and videos and made a photogrammetric 3D model. Now we can take measurements. So no confined space entry anymore to take those measurements or guessing from up top. We ended up realizing that with Fulcrum tailoring the forms for us, that we can now, we're emphasizing the fields that need to be filled out and making sure that it follows a logic process that makes sense. So let's say the manhole cover is missing. That's an exaggeration, but it's happened. Hide all of the cover fields, obviously. Does the manhole have a cone? Then go ahead and add those fields in and let's start filling those out a certain way. And then outliers. Let's say that the manhole shouldn't be 90 feet deep. We have alerts that come up when there's manholes entered beyond 50 feet, just things like that, but it's really handy. We found that with the 360 photos, Fulcrum guiding us in the field and in the office, we found a 30% labor efficiency gain. And we were seeing more observations. I didn't put a statistic in here, but on a case study with electrical, an older method versus newer method here, as we're showing, we gained 60% more observations just because we can look in all directions in the office. So we take screenshots of those 360 pictures, put them in Fulcrum. A lot of this data integrity went up, and we're not visiting the sites much anymore because we have a 3D model of it in the office. So that's been a big win. But the accessories that make this kit happen. So Fulcrum is kind of our platform of truth, but we have to capture the media. So The GPS Bluetooth directly into a tablet. The cameras, as long as they're Wi-Fi enabled, can stream their live feeds into the tablet as well. So we'll take pictures from those cameras, upload them into Fulcrum. The GPS is real time. All those photos get tagged with GPS. So we know for sure that they were taken at the right structure. It's not like we joined the wrong photo, to a different manhole. And then there's these data events. So in Fulcrum, behind the scenes, when data events first came out, we were jumping for joy because now we can program behind the scenes that, let's say, field crews, it's a hot day, they're in a hurry, they inspected a manhole, they totally forgot to set up the GPS. But when they go to click save in Fulcrum, our back-end data event reminds them, take a GPS shot. You forgot that. So they take it, they save it, and they move on. But what if they were in a hurry and the GPS was a poor shot? So based on its accuracy, the second data event says, hey, warning, you didn't get a survey grade shot. Try again. If photos weren't attached, it forces them to submit them. But what if they're portrait instead of landscape? We've had clients that prefer to have landscape pictures to keep consistency. Anyway, so it will remind you, look, you had a portrait photo, and then reject that and make you take it in landscape. So there's a lot of things. That's just the tip of the iceberg of what data events does for us. But the other part of this is the Esri integration with GIS and maps that are submitted to us, start off being more poor quality. Some of them are older. Maybe they're out of date by 20 to 50 years. Some of them are just sketched from old paper maps. We found that if we take Fulcrum inspections and the GPS from Fulcrum, weld that into an ArcGIS online map, now we have this double truthing going on. So the old lines, the old routing of the manholes, we now see the new GPS shot in real time showing up in Esri in any platform, whether it's Arc Pro or Arc Online. From there, our office technicians can use ArcGIS Pro to start connecting lines and drawing things. So can our field technicians. From there, we've got this streaming view that in real time, we can compare both the before, the after, and share that with our clients. So in this case, clients can look at that screenshot in the top right and say, wait a second, I thought we did have 2 manholes out there or inlets at that curb. Sure enough, we don't. We only have 1, or how that story goes. But the other big benefit, because the data is streaming from Fulcrum as either a live CSV or a feature service layer with the shared views, we can query that. And we can query it in Power BI. We can query it in Esri dashboards, ArcGIS online dashboards. So in the bottom right corner, there's a picture that our project managers use to see how are things going. How many did you get done today? Should we start adjusting for extra field crews to catch up? Or why are there so many on this corridor that could not be opened? Maybe they were all paved over or welded shut. A lot of visual forensics that go with this too. So that's how we use it in part of this case study. I'll turn it back over to you.
Hello, everyone. I'm Zac McCormick. I'm the CTO of Fulcrum, and I'm going to talk a little bit about how we're approaching AI at Fulcrum and build on what Coleman had mentioned and some of the stuff that Jared had talked about. So central to our AI strategy is the notion of embedded and on-device AI inference. And so Fulcrum has been supported offline from day one. And that's been an important reason why we've had success and why customers like using the product so much, is that it's going to work because everything's running on the device. And so that's been a guiding principle to some of the stuff we're looking at with AI. And it's not to say that we're not going to do anything online where it makes sense. We might take advantage of hosted AI and to get better results. And I'll actually have a demo of that in just a moment. But we're really focused on where we can do things offline and on the device where it's possible and feasible. And so use cases we're looking at with applied AI is asset identification is a primary one that we've looked at. So we talked to quite a few early adopter customers and given them early access to a few different of these capabilities, and asset identification came up as an important one. And I'm going to show in just a minute what I mean by that. And also just about general validation comes up as well as a big one. But there's some other things here listed of use cases that we're looking at with being able to leverage all of the benefits of that AI brings to the table. And we have a couple of early access capabilities, object detection, image classification, and text extraction. And I'm going to demo these in a minute. And these are available in an early access fashion. And there's some contact information at the end of the deck that you can reach out if these things interest you, and we can work with you to get access and to better understand your problem. And we're also researching some other things that are slightly more out on the horizon, but not that far out on the horizon. And I actually am going to demo an early version of this audio transcription concept in a minute. So I also wanted to walk through just a sample business case that we've built to show how efficiencies come through and flow through when taking advantage of AI in field activities. And here we have a couple of baseline assumptions outlining like a basic cost structure of a field crew in a truck. So you have $200 an hour per truck, 8 hours per day, 5 days a week, and the math comes from there. And so you're looking at a total of the current state being roughly $400,000 a year for 6,000 inspections. And that's a manual process, and it's even optimized using all the things that Jared mentioned. It's a very digital approach, but still there's lots of manual entry on the device. So how can we improve that using all the capabilities of AI? And we think when you bring in AI, there's a lot of opportunities for savings using whether it's computer vision or some of the dictation stuff I'm going to show. Just in this model, we're saving $13 per inspection or $80,000 per year per team. And look at that from a different angle, from a productivity, output perspective, and you got 1,200 more inspections per year per team. So that's a basic kind of thinking of how we're looking at field efficiency as a primary driver for AI and Fulcrum. And our vision has been trying to make it pragmatic. What can we do? What can we do and make it very real? And so we're not doing a lot of like just demoware kind of things. We're making real stuff that's going to solve a real problem. And so we've been doing AI for a while, and we actually have the main ML capability that we deployed a couple of years ago was facial blurring on Android and iOS. So those photos you take, if you enable that, are automatically blurred, and that data is never even sent to our server. It's all happening on device using iOS and Android local models. So we're really looking to improve productivity and reduce errors is really the primary objective. And also, we really, really want to run the models on device where we can. It's not always feasible to do that, but when it's possible, using the available technologies, we would prefer that it be offline. And we're partnering with our customers on this whole effort around our AI strategy, getting it in the hands of people as soon as possible. And now I'm going to hand it back over to Jared, and he's going to talk about a few things they're doing in this area.
Oh, I skipped ahead. Sorry about that. And we're back on the right slide. So how we're leveraging AI is new to us as well as it is to a lot of people. In just the last year and a half, we've seen advancements with ChatGPT and AI just is soaring. But for us, it's about validation and verification that what we saw in that manhole is the correct defect so that our clients can say, okay, we know how many leaks in the system we have or how many structural defects we have in the system. So defect detection, just to have another set of eyes on it, there's strength in numbers, right? Or just making sure the materials are correct. If we thought it was a cementitious liner on the manhole, was it called out correctly in the database? Observations that are missed can also lead to big mistakes later. If we don't catch this rebar, for instance, that's exposed in this manhole, what happens to it in 5 years, 10 years? That manhole will start to fall apart. The bad news is our cities were not born yesterday. They weren't built overnight. So things are getting old. We got to catch everything that we can. So critical observations are another thing. We have foremen and project managers who want to know 0 day. Let's find out what the worst defects are. Let's fix those now. because they could be infrastructure problems for cars driving overhead or pedestrians walking on sidewalks even. So we try to get that stuff early, but with Fulcrum, if we detect it, we can send automatic reports and just forward them straight to the powers that be. And that's really nice. So to give you, for instance, what you're seeing is one of our 360 photos. This is flattened, kind of like a globe flattened out to a paper map. The middle is the north side, then you have east and west in the thirds, and then on the farthest left and right is the south side of the manhole. You're looking at the wall. This is a brick manhole. Can you spot the defect? That's the question that I ask. Using AI to go in there with high resolution very quickly, it can detect a hairline crack. Why does that matter? Well, you and I and everybody else on this call, we're all paying a water bill or sewer bill, and every time there's cracks in the infrastructure, rainwater comes in, and you and I pay for that. That extra rainwater shouldn't be there. So finding these cracks, we can patch them up, but sometimes it's hard to see with our own human eyes because we're in a hurry, or it just at some point it just becomes monotonous. So another example, the severe stuff. When we do these scans in the field, we see things that are obviously severe, but sometimes we don't realize how severe. There's a lot of defects in this picture, but I'm going to draw your attention to the middle defect where there's a crack on the left of the slab, a crack to the right of the slab over the center of cracked brick. At some point, someone walking along this sidewalk can fall in. At some point, not today, maybe not tomorrow, but if it keeps deteriorating from maybe an earthquake, anything, we need to get that corrected fast. So having Fulcrum detect these images and then classify these defects could automatically forward this to the powers that be and get that answer faster. That also cuts down a lot of time. So in the office, it takes a lot of time for these older structures to code every single defect. Let's say there's 15 of them, and every one of those we have to put a description. Where was it? How severe is it? But if Fulcrum and GPT or other technologies can merge together and make quick work of that, that's a huge labor savings, probably 5 to 10 minutes of extra review time. So that's where we stand on it, and we're excited for this next piece. Zach, back to you.
Excellent. So I had mentioned that we had started with a couple of primary use cases, and here we're looking at the first one, object detection use case and doing asset identification. So what we're looking at here is take a picture of a utility pole, and this model can identify the different attachments on the pole, classify them, return them as a structured data that you can use to populate an inspection form, pull out information, and even make decisions using smart logic inside of the forms to activate other required fields or capture more photos. So really automating monotonous and error-prone collection and just making it overall more efficient. And a second use case that we're looking at is text extraction. So take a picture of the poll tag, prompt the user to verify it, and it just populates the field. So very quick, and a simple nod yes there automatically fills in the field, and there's no errors with the keyboard entry or manual entry there. So that's just one example of the use case of text extraction. Now I'm going to hop over to the demo. I'm going to show those things that I just had the screenshots of. And let me just share my screen here. Okay, so here I have my my Fulcrum app. I'm logged in. Here's my iPhone, and I've got my device synced up. And I had mentioned that we're doing embedded AI. So I'm going to show an example here of a utility pole model that I built and trained and uploaded to Fulcrum. And this model is running offline. So I've built out this form, synced my device, and now I have this model file local, and I can use it during my inspection process. So I'm going to create a new record, and when I attach a photo of the pole, it's going to run that inference session on that photo and return, and you can see it found a wood pole with 8 attachments. So it automatically pre-populated this pole type as wood and added these different attachments here. And then, so if there's subsequent collection required for each one of those assets, that, you know, you can drill in here and it populated these child records that are associated with this parent pole that we're inspecting. So really, really nice efficiency gain there. And for text extraction, here's another photo field I have to take a photo of the pole tag. So I'll pull that up, take a picture of the pole, and it extracted that text, and then I confirm that that's the pole tag, and then it automatically populates that right in the form field, and I can move on with the inspection. So those are the two demos using our computer vision AI capability, and those two demos are both running on locally on the device. And now I'm going to show actually a different demo using dictation. And this demo actually is demonstrating an OpenAI integration using the ChatGPT API. So this is very different, being able to use voice inspections. So I'm going to record here and just read off a script here to do an inspection. It's a wood pole in good condition with pole tag 41733. It was installed June 2017. It shows mild rotting and cracks. It has a transformer that serves 4 customers. There's also 2 lightning arresters and a double cross arm. Let's schedule a follow-up for mid-September. General comment that a neighbor has a barking dog, but it's behind a fence. Set the status to completed. So now it's making a call out to OpenAI and processing that dictation that I gave and coming back and automatically filling in the record. So you can see the record turn green. It filled in, it was able to understand multi-choice field, rotting and cracks. It added the different pole attachments that I said, customer served. The pole tag was repopulated. It's understood mid-September, and it filled in the comment. So you can see, you know, really nice ability to fill in more monotonous aspects of your inspection. And then the only thing you have to fill in manually is maybe more nuanced things within your inspection process, and you can really accelerate the speed of filling out the inspection.
Zach, I hate to interrupt. There was 2 questions that just came in saying they can only see the demo slide, as if they couldn't see your live screen share there. I'm not sure if that was something.
Nope, so that they must have the media box minimized, so they would just need to maximize that. Again, the demo is in the media box and not on the slides.
So was it working or no?
Yes, everything is working.
Okay. Whoever that was, I'd be happy to do another demo. Maybe, you know, if you want to contact us to learn more about it, or, you know, watch the replay afterwards. I believe the recording should be available soon. So yeah, that's the demo of dictation. I think this is a real needle mover with improving the field work. So and also connecting to these state of the art models that are available. So yeah, with that, you can go to the next slide, which is actually moving to our Q&A. Coleman, you want to take this?
Sure. Thanks, Zach, for going through that, and Jared for giving us some context on how we might apply that even in practice today. A lot of the computer vision stuff, I think that, like Zach said, this kind of auto-filling capability that he just showed with GPT is super interesting, because it basically gives every customer a way to configuration free be able to get level up the collection workflow. And we're even exploring ways to do this with where, rather than do like what he showed, where you kind of dictate the whole thing in one go, you give it just bursts of voice and it fill in sections, kind of, let's say you're walking around a job site or something like that. It can, you know, gradually fill it in as you make almost like walkie-talkie style dictations into your device. Yeah, I mean, it could be a huge game changer. We have so many customers doing extremely detailed inspections that you know, can get tedious, to say the least, with all the amount of repetition. So Here, well, as we move into the question and answer session, I wanted to leave this slide up. This is just some information to leave behind with you all today with how to get in touch with us or engage with us on any of, in general, but also on any of what we've seen today. If you are interested in some of this AI stuff in particular, given that that's not a lot of that is not in production environments yet, but we're working with customers one-on-one to do kind of proofs of concept and experiment with it. Get in touch with our product manager, Adrian Zuniga, is listed here. He'll be happy to engage with you, and Zach as well, and then Jake from our product marketing team on any other inquiries. So I also left a link here to TREKK, the case study that we've done with TREKK that dives into greater detail on some of what Jared showed today. So thank you all. And we'll take some questions now, if there's any.
Thank you. Just a reminder to use that Q&A box to ask your questions. We'll get to them shortly. We had a couple come in early on that I'd like to go over. So a few people have asked about integration. So who does the integration work for these interfaces?
That's a good question. Some of them are native, so some of them work already, right? Like out of the box. So things like the GPS devices that can be connected via Bluetooth. Some of the integrations like Esri integration on the software side are native to Fulcrum. And then there's a host of integrations that we've built in consultation with customers through our professional services team. So if you have any questions specifically about any products or services that you need integrated, just get in touch with us and we can talk in greater detail about those specifically.
Thank you. And kind of around that, what concerns do you have about model compatibility between platforms?
I can take that one. So we aim for maximum compatibility just because Fulcrum is a cross-platform product, and we aim for complete parity with Android and iOS and even web. So any models that are built, the expectation is that they would work on everywhere Fulcrum works. And in early access, we don't have everything working on the web yet, on the web platform, but on iOS and Android, where it really matters for these use cases, the same model will work on both platforms. And we also strive for compatibility with existing models that have been built using other computer vision platforms. There are several from the big cloud vendors, and we aim for compatibility with those. And that's the ones that we've been testing in our pre-release period.
Thank you. Question came in, does AI work while out in remote locations?
So I gave a couple of different demos today. Part of it works completely offline, and then the other part requires an internet connection. So the computer vision stuff we built in a way where the models are running on device, and that's all running offline, and everything is synced. So when the device syncs, it pulls down the model file and is able to run it all offline. The dictation demo that I showed, that one requires an internet connection because it's using OpenAI directly. And so that's how we're approaching it right now, because that's where we've been able to get the best results. And we're also exploring in the future different ways that we could run similar functionality completely offline. So the way we're looking at it is maybe an end state of this is there's a hybrid approach where when you're offline, you get a model that is maybe not as good as the latest ChatGPT, but it's still functional. And if you're online, you get access to the complete high fidelity ChatGPT 4.0 or whatever the state of the art at the moment is. So that's how we're approaching it.
Great, thank you. We have a question if you have any examples where Fulcrum has investigated a refinery or chemical plant.
I don't know in specific, but we have done, we have a lot of customers in the past that are in the facility space that have done basically facility management work using Fulcrum. So if that is a helpful answer, then yes, but I don't know specifically in the fire instance.
Let's see. If I already have a model from another platform or project, can I deploy that in Fulcrum?
Yes. So we do work with the pre-existing models. We have a very large customer in the utility space that has exactly this challenge, and they're bringing in an existing model from prior internal investments, and it's they're having success getting it working inside of Fulcrum as is. There's a particular technology we're using called Onyx runtime in iOS and Android to actually execute the model, which is a Microsoft sponsored project. Anyone can go look that up if you have time and want to learn more about it. But any model that can be converted to an Onyx, ONNX is how you spell it. Any model that can be converted into that format can be used in Fulcrum. You can kind of think of it as the Word document of AI. And so you can share these files around to different applications and use them. That's the best analogy I would give for what that file format is to AI.
I'll give everyone another moment or two to maybe enter in a final question to see if we have any more coming in. A few of you did ask if you'll get a copy of the on-demand webinar, and yes, within 2 business days, everyone will get an email with a link to access this platform and replay the webinar and download any of the resources. If you haven't already, you'll get access again in 2 business days, and you'll be able, those who didn't happen to see the media player, it will be played on the replay if you happen to miss the demo part. Let's see, a couple more questions. Can cardinal compass points be discrete as in degrees, and some environments think upstream or down?
Jared, can you answer that?
So I know the first part of the answer, yes. The second part of the answer, creative. So we've done pole inspections where you've got not necessarily downstream and upstream, but in a sequence, you're doing a previous pole ID. In wastewater as well, we have a child table that's always looking for the upstream pipe and the downstream pipes, but you're classifying that. We actually take that a step further. So the child records, whenever we get our pipes on manholes, one's classified as the incoming pipe. Several others are, many are classified as incoming. One could be outgoing. 2 could also be outgoing. We do a pipe draw model, and we will literally in ArcGIS Pro draw all the pipes between the child records and their IDs based on those in or out statuses. And it helps us check to see if we got the IDs right or if the direction correct. So it's an iterative process, but we also use our eyes on that too. So you can be creative. It's flexible.
Great. We have somebody who's asking the approximate number of end users Fulcrum has. Is that something you can answer?
Yeah, we can answer that. We have. Oh, okay, go ahead, Coleman.
Okay. Yeah, we have several thousand customers, either companies, organizations, however you want to classify that, with many thousands of individual end users. So they range from, an organization could have 2 or 3 users all the way up to several thousand field users using Fulcrum concurrently. So it runs the gamut.
All right, it looks like that was our final question. But if you think of any additional questions, the contact information is up on this live now, and you'll also have access to this when you receive the on-demand link. I do have a few housekeeping notes to go over before we officially close out. As a reminder, everyone will get the on-demand information within 2 business days. So look for that from Geo Week News. Also, if you could please fill out the short evaluation form that will appear on the webinar console shortly. This will help us serve you for other webinars. Your feedback is greatly appreciated. I do want to thank our speakers today. I want to thank Jared, Zac, and Coleman for a great presentation. And I want to thank all of our attendees for taking the time out of your busy day to join us. Again, this webinar was brought to you by Geo Week News and sponsored by Fulcrum. And that is all I have for today. Thank you.
Thank you.
Thank you.
Thank you.